Hi everyone, this is Kalyan this side and welcome to Chemistry Universe. You are watching the chemical properties of aldehydes and ketones. This is part 17. And in this one, we're going to exclusively discuss benzaldehyde. But there isn't much that is different in benzaldehyde that we're going to do. Most of the reactions and preparation we've already done. But benzaldehyde we're specifically doing because it's a very important aldehyde among all aldehydes. And therefore we need to do it separately. But I'm just going to, keep saying that, okay, this is the reaction and we've already done this. This is the reaction, we've already done this. So while watching the video, if you are able to remember it, great. Otherwise, go and watch the preparation of aldehydes. I've done that in one go. So you can watch that and that will help you understand the preparation of aldehydes as well as the reaction of aldehydes, which you can also watch the properties of the chemical reactions of aldehydes and ketones. All right, so let's get with the video. First, we look at the preparation. We have done this by the Gattermann-Kosch reaction. I'm just going to give you the basics of this. We reacted benzene with carbon monoxide, HCl and AlCl3, and we got this. So go and check that out. It's called the Gattermann-Kosch reaction. Then we also did Etard reaction, if you remember, chromyl chloride. So you needed a methyl aromatic aldehyde. Only with aromatic aldehydes it's going to happen and you're going to get benzaldehyde. By Rosenmund reduction, remember we did the Lindlar's catalyst in this. Acid chloride reacting with H2PDBSO4 and poisoned with quinoline or xylene as required, and you will get benzaldehyde. We have done the Stephen's reduction where we started with a cyanide and SnCl2, HCl, and then hydrolysis, and you got benzaldehyde. Then remember we did dry distillation with the calcium salt of formic acid. You take calcium salt of benzoic acid, reacted with calcium salt of formic acid, dry distillation, heat, and you will get benzaldehyde. Now, this is something which, of course, you may not have done, but it's pretty simple by Alkalidene Dihalide. In fact, we've done this, if I remember, in the preparation. You just have to prepare this. This is Alkalidene Dihalide. Alkalidene Dihalide means geminal dihalide, okay? And you do the hydrolysis of this aqueous KOH, 2OH replace the Cl, the 2OH are not stable, they release water, and you get benzaldehyde. Then we've already also done by mild oxidation of primary alcohols. We use PCC, PDC and stuff, and you got benzaldehyde. Then there is a Gattermann-aldehyde synthesis. Gattermann is all over this aldehyde thing. So you can get you take benzene, you take HCN, HCl and AlCl3, and then do hydrolysis, you get benzaldehyde. So that's the important part. As far as physical properties are concerned, they're very, very similar to other aldehydes. Nothing very specific other than the fact that they are known as oil of bitter almonds. Potassium cyanide is, as you know, a poison. And people who take potassium cyanide and kill themselves, you get a smell of bitter almonds from that. And benzaldehyde sometimes is confused with it, because benzaldehyde also has a smell of bitter almonds. So that is the important part, and it's basically an oily stuff. And when it comes to chemical property, I'm going to show you all reactions in one go. And we have done all of them, in fact. There's nothing unique in any of these reactions that we haven't done before. So I'm going to show you this. React with HCN, you get a cyanohydrin. It's basically cyanohydrin. Reacted with sodium bisulfide. Remember, you get a bisulfide addition product, which was a solid, a crystalline solid. Then you have a derivative of ammonia. Can you see? You got a derivative of ammonia here. Then red phosphorus HI we did in the preparation of alkanes. You'll convert all of them into alkanes. Then you know that if you do oxidation, you will get carboxylic acid. If you use PCl5, it will remove the C double bond O and make it into 2 Cls. This is one way of getting a geminal dihalide. And then you use tolerance reagent, again oxidation, you get same silver mirror test. We have done this and we have done the videos of this also. reacted with NaOH, remember it is going to give you Cannizzaro reaction. And if you use an amine, you will get a product very similar to the a derivative of ammonia. Then you do the Schiff's reagent test. You'll get the pink color because it's an aldehyde. You do Grignard's reagent addition, and you will get a secondary alcohol because it's an aldehyde. Then you use anhydride. Remember, we did Perkin reaction. This is the Perkin reaction, alpha beta unsaturated acid. And then you have nitration. Now, this will happen on the benzene ring. It will give you meta-nitrobenzaldehyde. Then if you use fuming sulfuric acid, you'll get the meta-benzene sulfonic acid. Of course, you have the formal group also. And do chlorination, again, you'll go the meta way, the meta-directing group. And you reacted with ketone in the presence of NaOH, you will get this particular thing. It is just the C minus attacking the carbon. It is the aldol type reaction. So that is basically part 17, and that is benzaldehyde. So I hope these short videos help you in getting through this big lesson. And so benzaldehyde is a very crucial element in that. And the next one and the last one will be the test for aldehydes and ketones, and almost most of which we have already done, but I'll mention them. But again, you need to go into those reactions of ketones. Many of these tests I've shown in the form of a video where you can see Felling's test happening, you can see Tollens test happening, you can see Schiff's test happening. So make sure to watch oxidation of aldehydes and ketones carefully, because most of these tests originate from there. So with that, this is Kalyan Kumar signing off. Have a great and wonderful day, and thank you for watching this.